Show that the following are equal. The integral from 0 to 1, the square root of 1 plus x squared dx, and the integral from 0 to pi over 4, secant cube theta d theta. First, the function the square root of 1 plus x squared as y equals the square root of 1 plus x squared can be rewritten as y squared equals 1 plus x squared, assuming that y is positive. This is a hyperbola, and so we're looking for the area under the hyperbola above the x-axis, but only from 0 to 1. First, we observe that the first integral has the form a squared plus x squared, where a equals 1. So we let x be a tangent of theta, where again a is 1. This is simply x equals tangent of theta. If x equals tangent of theta, then dx equals secant squared theta d theta. We then draw a generic right triangle and label one of the acute angles at theta. Since tangent of theta equals x, or x over 1, and tangent of theta is the opposite over adjacent, we would label the side that is the opposite to the angle theta x, and the side that is adjacent to the angle theta 1. The hypotenuse is therefore the square root of 1 plus x squared. We need to express the square root of 1 plus x squared as a trigonometric expression, but the square root of 1 plus x squared is the square root of 1 plus x squared over 1 as the ratio. And we see that this is the ratio of the hypotenuse over adjacent, so it is secant of theta, because cosine of theta is adjacent over hypotenuse, and secant is the reciprocal of cosine. We now have all the pieces to rewrite the first given integral in terms of trigonometric expression. The integral, the square root of 1 plus x squared, can be substituted with secant of theta. This is the first substitution piece. Next, dx can be substituted with secant squared theta d theta. This is the second substitution piece. Next, since the variable of integration is theta, we also need to substitute the limits of integration. If x equals tangent of theta and x equals 0, then theta needs to be 0. When x equals 1, theta needs to be pi over 4, because tangent of 0 is 0 and tangent of pi over 4 is 1. So the lower limit of integration is 0, theta equals 0, and the upper limit of integration is pi over 4. Rewriting this, we have the integral from 0 to pi over 4 secant cube theta d theta, which shows that the first integral equals the second integral, and that is what we need to show.